We'll kick it off with Jill Becker from Cabotics. Jill, take it away.
Thank you, Don, for your great keynote. Great to see you, even if remote. Thank you, Jim, for the invitation to be here. It's a pleasure. Hello, everyone. My name is Jill Becker. And let me just share my screen. And I'm excited to tell you about Cabotics, where I'm CEO. Just like Ambry, Cabotics was born out of science, but from a little known university down the street from MIT, and I hope you guys don't hold it against me. What we wanted to do was to disrupt the scientific method and increase the rate of discovery of chemicals and materials and associated processes. As you all know, the problem is R&D is too slow and too expensive. And you also need to cross what we call the R&D productivity chasm, which people spend about $150 billion in order to get new materials into end products. Chemical companies are good at what they do, large-scale production, material and chemical sales, but they're not innovative enough. There's not enough success, and the discovery is too slow. It can take 10 to 15 years to bring a new material into an end product. So they needed a new player, and that's where we came in. As Cabotics, we combined AI and robotics in order to have built now the first self-driving lab. We also call this our closed loop innovation platform. And what you're looking at in this circle is the scientific method, but instead of someone very romantically dreaming up a hypothesis for a new chemical, and I have a PhD in chemistry from Harvard, so I'm not knocking basic research, but it shouldn't take 20 years for you to get paid for a good idea, which is what happened to me. Anyways, we have AI and physical methods to predict what you should be making. And then we hack into off-the-shelf robots that make the top candidates. We have another robotic suite that tests just like a chemist. Did you make what you said you're going to make? And does it have the properties of interest? And you're left with an actual prototype. Underneath this, we have about 14 tools, part of our chemical operating system, and we can use them as standalone or in any combination in order to get cleaner, faster solutions for chemicals and materials. I'll go through 3 quick examples for sustainable success use cases. As you know, if you're a chemical company or a PhD student, if you want to know how a chemical behaves, you have to make it. A company approached us. We were able to predict the 3 properties of interest. They were boiling point, vapor pressure, and viscosity for 2,300 chemicals. We ranked them for them, made a demo website where they could toggle, and we did this in 3 months. The top 4 they made, they were total hits. Our prediction was totally accurate, and we did this with just one tool, our property prediction tool. We saved the company years and hundreds of thousands of dollars. I'm going to skip over company Y right now. Since we have such a strong prediction tool and we have a lot of internal IP generation, we decided to upload more than 7 million commercially available chemicals and ask our AI software, hey, can you do a needle in a haystack search for us? Come up with a new novel electrochromic material for smart window applications, something that's transparent and with a small electric current would let the light through, but not the heat. So you can imagine the energy savings, both in summer, not letting the heat in, but also in winter, not letting the heat out. We found that, we patented, so it's exciting that we can patent new use cases in other people's structure case IP, but our AI software gets even better because it's set up to learn. So it generated a new library of candidates that meet this requirement where we own both the structure case IP and use case IP. So this is what we had set out to do in our seed round, that the AI dreams up new chemicals by itself, and it did that. The same tool out of the 14 plus tools we've built. Of course, we've also built a tool that does synthetic route prediction, both forwards and backwards, known as retrosynthesis. And we worked with a big oil and natural gas company to dream up a cost-efficient way to come up with a green monomer. This, of course, is all sustainable. We're also really interested in green molecules for biofeedstocks, like cellulose, lignin, alginate. I believe Sweetwater is perhaps after me. And then using parts of our platform, come up with eco-friendly colorants, eco-friendly optical brighteners, photosensitizers, etc., all non-toxic and environmentally friendly. We have the domain knowledge. There's a lot of market regulations, both the push and pull. Cabotics, although we are a United States company, we do align ourselves with the United Nations Sustainability Goals. I actually forgot to put on my UN pin, but these are COVID times. And what we're really looking for, we just closed our Series A, and we're looking to continue to grow our partnership. So really, how can we help you create clean and sustainable chemistries faster at a reduced cost? We're always interested, and we have a plethora of tools that we use, both digital and complete solutions, whether that's optimization of processes. And yes, we can do all this remotely. And no, we don't need your data. We can generate our own data. We just need to know your problems and how we can help you innovate. Thank you for that.
Hello, my name is Jack Barron. Thank you, Jill, for that. I'm the co-founder and president at Sweetwater Energy. Our chairman and CEO, Arūnas Čisonis, is an MIT alum and a member of the board of directors. Sweetwater Energy has developed a true platform technology that breaks down biomass into its component parts. For the first time, wood and crop residues available all over the globe can now be broken down economically to create ingredients for products that compete directly with petroleum-based products. The technology is feedstock flexible and scale flexible, meaning it can work all over the world, and companies can start small and grow to virtually unlimited demand. This platform technology that Sweetwater has developed again transforms biomass into high-value building blocks that replace petroleum-based ingredients and improve product performance at lower cost. This means that green no longer requires a premium. With a partner in Europe, we have now established that the technology works at commercial scale, processing over 75 tons of biomass per day, or 50,000 green tons per year. We address is current biomass processing is inefficient. It's high waste, high cost, and carries a significant negative environmental impact. Sustainable products, as a result, that are made from wood and crop residues can't compete economically with low-cost oil in markets for fuels, chemicals, paints, and beyond. As a result, green solutions often carry a premium, and they can't address climate change on a global scale. In order to become truly global and address climate change, they must be economical. Our technology is based on twin screw extrusion. We have issued patents around the world. And now, as I mentioned, we have in fact established that the technology works at commercial scale. We break down biomass into its component parts: cellulosic sugars, lignin, and perhaps what we're most excited about, specialty cellulose, microcrystalline cellulose, and nanofibrillated cellulose. The sugars are readily fermented into biofuels for transportation and to biochemicals. We've been doing that on our own and with partners. We're working with a number of global partners now to create resins, paints, polyurethane foams from lignin. And the specialty cellulose has been proven to work effectively to lightweight packaging to lower cost. It does the same thing in wood and processed wood products for building materials. It also works for cement. And in fact, a 0.5% inclusion of our microcrystalline cellulose, the tensile strength of that cement. So 0.5% in, 100% increase in tensile strength. The Japanese government recently announced that they produced an electric car whose body was made out of nanofibrillated cellulose, much like Sweetwater's. The reason for that is this product is up to 5 times the strength of steel at 1/2 the weight. You'll even find microcrystalline cellulose in products such as Kraft Parmesan cheese and Beyond Burgers. We're working with multiple partners around the globe, partners who are finding benefits from our technology that increase sustainability while increasing savings and performance of products. Specifically, lightweighting paper and packaging products allows one of our customers to save their customers up to $5 million per year each. Our nanofibrillated cellulose acts as a coating to reduce or eliminate petroleum-based ingredients, saving cost, and improving oxygen barrier performance in packaging. We're currently seeking additional collaboration opportunities. Companies that wish to lower the cost of their new and existing products to increase profitability, to improve their product performance and sustainability, to create new proprietary products for market leadership. The industries and applications that we're focused on are packaging and paper, processed wood for construction, furniture, auto parts, cement, which I mentioned, fuels, chemicals, polyurethane foams, bioplastics. We're finding that if you can get a product that is in fact better, cheaper, and more sustainable, a lot of people are interested.
Hi everyone, I'm Kristen, one of the co-founders of Sati. We're based in the US and India, and we are a sustainable manufacturer of hygiene products and pioneers of upcycling natural fibers into consumer products. For this presentation, I'm going to focus on our first product, which is sanitary pads. At Sati, we're addressing three major issues. The first is that women in urban areas of India are using conventional pads, which are mostly filled with plastics and chemicals, and this can cause rashes and UTI infections. The second is that only 18% of women in India have access to sanitary pads, which can cause reproductive tract issues and also keeps girls and women away from school and work. Finally, our beaches and our waterways are suffering because plastic pads take 600 to 700 years to degrade. We're addressing these issues in a holistic way. We manufacture 100% biodegradable and compostable pads, which are soft, rash-free, and don't cause any harm to the environment. We are able to do this with our patented technology to convert natural fibers into an absorbent material. We recently launched masks in response to COVID and have a number of other exciting products in our pipeline. This is an overview of our business model. We are sourcing the fibers from farmers. We're bringing the fibers to our factory, processing them and making our pads in the factory, and then selling them online to urban consumers and to rural women through our NGO partnerships. At the end of the day, the products can be upcycled into a number of various waste energy systems. If we look at our impacts, we have impacts built into our supply chain. So we're addressing 8 of the UN SDGs. In terms of banana fiber, we're sourcing these banana and bamboo fiber from farmers, so we're able to increase income for the farmers. We have an all-women staff in our manufacturing unit. We have a zero waste manufacturing process. And in terms of distribution, because we're distributing also in rural areas, we're able to improve health of those women. And finally, for the environment, because it's completely natural and biodegradable and compostable, we don't have any negative impact on the environment. So we didn't want to create one solution for access to sanitary pads while creating a waste problem. In terms of partnerships, we've had conversations with a couple different global companies on projects ranging from plastic credits to sustainable materials, R&D to white labeling. And we have a number of areas where we can provide value, including tech partnerships for multiple industries where we can supply sustainable raw materials or do joint R&D projects. In terms of CSR programs, looking at wash to menstrual hygiene management, working with employee health and wellness, because we do workshops and also can provide the product, and collaborating on waste management and compost solutions for a circular future. We are able to provide both carbon and plastic credits due to the fact that we've been measuring these metrics since starting. We're also looking for support in quality control, talent acquisition, and distribution. We aim to make our products accessible globally so that everyone can be eco-friendly.
Hi, my name is Darcy Prather. Thank you, Kristen, for that wonderful story about a very important concern. So today I'm here to talk to you about Calian. Calian is working on high purity, low cost glucaric acid. This technology was developed in Professor Crystal Prather's lab here at MIT in the chemical engineering department. glucaric acid was identified by the DOE as one of the top value-added chemicals that could be made from biomass. The reason that it achieved this distinction was that it can be used in a number of applications. Traditionally, it's been used in pharmaceutical uses and nutraceutical uses. We've recently discovered it can be used for a phosphate substitution for corrosion inhibition when you're treating water. Along with that, we've also found that you can add it to textiles and a range of polymers and greatly enhance the mechanical properties, whether you're measuring modulus or tensile strength or similar things. So all those are near-term targets for us, which we'll be commercializing in the next year or two with commercial partners. There are also longer-term objectives that we can also hit, whether it be detergent builders as a chelator or in the production of FDCA or nylon 6,6 via adipic acid, or concrete additives for enhanced strength there as well, or as adhesives. Of course, it's able to do this because glucaric acid has a number of hydroxyl groups, and that contributes to the ability to bind with iron, thus the corrosion inhibition, and the adhesion and the cross-linking leads to increased properties when you're putting in small amounts, anywhere from 1 to 10% in certain other classes of polymers. And we're able to produce this very cheaply because it is a very short pathway within the biological systems. We use E. coli, and to go from the sugar to the final product is less than 5 steps. There's a high theoretical yield. If you look at many bio-based products, theoretical yields are often less than 50%. Ours is over 100% because we're able to steal that oxygen from the air. And we're going to start making those glucarate salts available next year. The problem that I'm going to focus on today is, in fact, in the textile world. Our clothes that we take for granted end up consuming nearly 10% of the carbon emissions that are used throughout the world each year. And in doing so, we obviously are contributing to global warming. One of the challenges in recycling that is cotton becomes shorter and shorter fiber lengths each time you attempt to recycle it. So very little of the cotton could be used, and absolutely a very small amount actually is used. Our solution allows it to turn into an MMCF, a man-made cellulosic fiber with increased mechanical properties while retaining under wet conditions much of that strength. Wet condition strength is a classic problem of recycling textile fibers. Just give you one piece of data here. If you look at the loop strength test, looping is a critical piece of the clothing that you wear. And we're able to demonstrate a 5-fold increase in specific modulus, an order of magnitude improvement in tenacity when you're looking at the loop strength test using standard ASTM results. So for us today, we're looking at companies who are concerned about this recycling challenge that you're seeing in the textile world. We highlighted cotton as a particular example. There are many other organic fibers also are things that we can add small amounts of glucaric acid to greatly enhance. Additionally, there are other materials in which you get this increased strength. So whether it be polyacrylonitrile, polyvinyl alcohol, are all just a few examples of the types of materials in which, again, with these small additions, you get these great increases in performance. Of course, you're in water treatment. We'd love to talk to you about phosphate substitutes and phosphate substitutions outside of the water world as well. We look forward to connecting with many or all of you as we start to commercialize next year. We're super focused on glucaric acid, and we'd just love for you to try it in some of your materials. So thank you very much, and I look forward to any questions you might have.
Thank you, everyone. Good morning to all. I'm Adam Rowding. I lead business development for Boston Metal. And at Boston Metal, we are focused on commercializing the MOE technology that Professor Sadoway introduced, and commercializing that for high volume, emissions-free steel production. From those early days at MIT, as we commercialized the technology, we were very fortunate recently that our mission, really the impact of our mission, has been recognized by a number of very high-profile industry awards from Bloomberg New Energy Finance, from the World Economic Forum, and others. And that mission is to revolutionize the steel industry. And if you look at some of the other innovations that have been talked about today, some of those impact the electricity sector or the vehicle transportation sector. Those are 100-year-old, 200-year-old industries as they stand today. If we're going to change steel, that's really a 3,000-year-old industry. And the reason behind that is that the same basic formula for steel production that was used in the Iron Age is still being used today. And that's because carbon does a very, very good job of converting iron ore, the raw form of iron, into molten iron. But now with almost 2 billion tons of steel produced each year, the CO2 that comes from that reaction is over 8% of global CO2 emissions. And that's the mission of Boston Metal, is to change that formula. And the technology we're commercializing is called molten oxide electrolysis. Professor Sadoway gave you a few details on that. It's molten process, high temperature, liquid metal is the product. We use oxide feedstocks, iron ore in our case, and most importantly, we're using electricity rather than carbon to do this process, preferably clean electricity. As a result, you get a high purity iron product. And since there's no carbon in the process, you only get oxygen as a byproduct. And so we see the future of the steel industry looking a lot like what we're doing, and that's producing emission-free metals and doing that right in the greater Boston area. As we take that technology to market, steel is certainly our central focus, but it is a platform technology. We can address a number of different metals and feedstocks. We recently announced our first commercial partner for a high-value alloy called niobium, partnered with a mine in Brazil called CBMM. They have about 80% market share for the niobium market. We signed that contract earlier this year, announced that. We are doing our first commissioning of a system later this year. That hardware is on the ground in Brazil today. And what got CBMM's interest and what has really gotten the interest in the steel industry as well, one of the key variables is that this is a very selective technology and that we can take quite complex low-grade feedstocks and convert those into very high purity, high value add metals. And that's the work we're doing for CBMM and for others, being able to do that at a very competitive cost position and do that with a technology that's quite modular as you bring it to market. As we go forward, with steel being our central focus, it's a massive market, it's global, it's essential for civilization as it stands, but it is a very capital intense, low margin and risk averse industry. And so we've been fortunate to partner with some of the leaders in industry and investment world. Some of their names are given below. And as we take forward the technology, we're looking really to grow those types of partnerships, those that can help us focus on our core technology and innovation, and meanwhile accelerate the path forward into this industry. So if those are out there on the phone today or listening to this call that can help us in terms of engineering or supply of key components, feeding systems, tapping systems, or those that are in key markets where they can provide boots on the ground or support as we bring the technology to market and bring first demonstrations to market in the next several years. If those are of interest to you or if those match your expertise, please reach out. You see our website and my email below. Thank you very much.
Thank you to all of the startups for those great presentations. We're getting everybody back here for the panel session. So let me remind the audience, you'll be seeing a poll on your screens. Those of you who are ILP member companies would like to have introductions with any of the startups, please go ahead and complete the poll, and your program director will get back to you to facilitate that. We have several questions from the audience. Let me start with a few questions specific to the startups, and then we have some of the questions which really pertain to most of you, so we'll take those separate. But let me start, Jill, with Cabotics. Some questions with regards to expanding a little bit more on your sales process, since traditionally many companies haven't taken this approach to materials discovery. But how do you incentivize or get companies to think this way, to use your service? And also, more specifically, your machine learning methodology, how does it differ in your view from other existing solutions?
Sure thing. So I'll start with the second. The tools that we've built, no one has put all the tools into one platform is one. And of course, we think our software and the way we do the machine learning is better. and better for our standards is that it's faster, more accurate, and we've reduced the cost down, that each chemical that we dream up or look at costs 0.00001 cent. So you compare that to doing density functional theory, that'll still cost you $1. And if you're doing something experimental, that's at least $300 or up. And you're not counting all the lab and the lab technician and the chemist, et cetera, and the chemical equipment for analysis. So we've reduced the cost severely out of it. The other thing, what's very important to us is we don't want to infect our AI software. So we have ways to create our own data by high throughput quantum methods and other semi-empirical methods. We, of course, with our self-driving lab, also have experimental data that we trust. And then we spend quite a bit of time to clean external data. External data is from maybe partnerships or paid and open databases and papers and patents. And sadly, a dirty secret in science is that not all papers and patents are reproducible. So you wouldn't want to put that into your software. We're the only ones that we know of that have all these different tools. We have, in our synthetic route predictor, that's where we have our #1 competition, but we're the best in class, including we've beat the best MIT chemists as well. We actually did that test and I presented it to my board meeting. If you ever meet my CTO from MIT, he actually validated this, and I would not be allowed to use the words best in class unless he scientifically proved that to himself. In terms of the business model, so usually there's a meeting, and what we want from our partners is their problems, right? So that we can come up with a deliverable. So the lines are very clean. We don't need the customer data. I think that's very tough. And we don't want to give away how we do it, but I'll give you an example. We did a project with NIH NCATS, and we did this remotely. They have a giant robotic arm that does nothing but enzyme assays to check for viruses. And yes, they're doing nothing but COVID testing right now. So their brute force design of experiment takes them 49 hours. We managed to reduce that on just a few weekends down to 9 hours, giving them 40 more hours to save lives. And at the same time, we've reduced their amount of enzyme that they need by a factor of 5. We want to know their problems so that we can provide solutions. They own that IP of the deliverable, whether it's the top 10 candidates. And if you want to have top 100 candidates, that's fine. We just think our AI is so awesome. Those will be like real winners. But we've started to notice the human element that, bigger is better, hotter temperature often is better, things like that. There's a statement of work that gets written, signed off by both sides. And yeah, it's been fun. We have many use cases, often NDAs get signed, normal course of businesses.
Great, excellent, good. Thank you, Jill. Kristen, a couple for Sathi. First one of the challenges oftentimes in a business like yours relates to the economics of the logistics to collect the materials from the farmers in the field, transfer them to your plant, even before you begin your work. Could you tell us a little bit about how Sathi overcomes or meets those economic challenges of logistics or your material sourcing?
Yeah, so we source the fibers from farmers, but in terms of fiber, so basically with banana trees, they only give fruit once, and so we take the stem of the tree. We've been working with the farmers in terms of at least extracting the fiber out of the tree, and then purchasing that fiber and bringing it to our factory for further processing. So we've been able to kind of manage it that way in terms of raw material.
Is that in large part a function of working in emerging economies where just the basic cost of things and transportation is less versus, say, working here in the US, or you think there's something else going on?
Right now, in terms of the material itself, so we don't have endless amounts of land, and one of the ideas is basically in terms of sourcing sustainable materials. We're taking someone else's waste material and trying to upcycle that into our product, which again can be upcycled post at end of life. So that's something that we believe in strongly, but I think it's just being able to leverage the materials that are created on by the farmers normally for fruit, and we're taking away that waste. So we wouldn't ever look into having our own farmland necessarily until and unless like there was a shortage of bananas itself, but that's not something that we're.
Great, thank you. Adam, for Boston Metal, you're the one non-organic person here today in this part of the program. The Boston Metal process, are you working with scrap steel as a feedstock, or is it more universal?
Yes, so it's a primary steel production, and that means that we're using iron ore as a feedstock. So it's producing new units of iron. We can also use, the product that comes from our process is a liquid, very high purity liquid iron. So we can be used alongside scrap to help dilute out, contaminants or impurities that would be in scrap. But we are really focused on primary steel production, going from iron ore to new units of metals. That would be the blast furnace and the basic oxygen furnace today, replacing those.
Great, excellent. And we have just a minute left for one more question. What I'm going to do is we have a general question. So we're going to go around each of the startups just very briefly, please. Since we're really targeting corporate partnerships with yourselves, could each of you just very quickly to the audience, your ideal industrial partner? Jill, let's start with you and we'll go in order.
My ideal industrial partner is that we start with a partnership for the, maybe it's an optimization of a reaction or a process in order to increase yield that drives straight to the bottom line. But it could be, we're looking to solve problems, whether that is a better formulation. An ideal project for us, in my mind, would be that we own the entire, from chemical to formulation into the device, and we can use the AI along those ways. But that's a big project to start off with, so I'm happy to talk with anyone for smaller projects as well.
Great. Jack, with Sweetwater.
Thank you, Jim. Our ideal partner is looking to create more sustainable products at lower costs and improve performance. So they typically know that they already are interested in specialty cellulose or lignin, or even cellulosic sugars, but the specialty cellulose in particular. So they have some experience working with that, and they want to do the product development on their own to create their own products and patent those.
Great, thank you, Jack. Kristen, your ideal industrial partner with Sapti.
Yeah, thanks. Our ideal industrial partner, I guess, can come on either end of the supply chain. So we're looking at creating a system level change, and basically that's from either partnering on the raw material side, so in terms of new materials that are relevant for multiple applications, whether it's in cosmetics or whether it's in the hygiene products. And then on the other side, in waste management, it's very important that even though the product itself is designed to be compostable, that there actually are ways for this to be upcycled. So looking at partners in biomass to energy, compost, etc.
Great, thank you. Darcy, for Calian.
Our ideal industrial partner has identified a critical business issue or a business issue in which adding glucaric acid can be differential for them in the marketplace, and in which we provide them with the glucaric acid and they provide the manufacturing assets that provide that final product.
Excellent. Thank you, Darcy. And finally, Adam with Boston Metal.
Yeah, and for Boston Metal, it would be really partners that could utilize, early small scale production of green metal. So they could put that into their supply chain, and that would be willing to, help support putting demonstration facilities together and provide the offtake and the marketing of that metal.
Very good. Thank you, Adam. And thank you once again to all of our 5 startups for session 1. It was a great session, and we wish you all the best in what you're trying to do.
Thank you, Jim.
Very
Thank you,
good.
Jim. Thank you, audience.
Very good.